All right, this is the final example from 12.1 that we're going to look at. This one's a little bit more challenging in that we're going to be dealing with two unknowns. And so we're going to set it up, take a look at how we could solve through an example that's a little bit trickier. So in this case, we're given some information in the circle, the arc AB. So that would be this arc right here is 7.86 centimeters. Now, technically, there are two arcs. It could be the major arc or the minor arc. We're going to be assuming since, well, I'm just going to tell you that we're dealing with the smaller of the arcs. So technically, that should say the minor arc, but we're not gonna worry too much about that. So that is going to be the shorter arc. We could be considering the larger arc all the way around, but that's not. So, in this case, the arc length here between A and B, this shorter length is 7.86 centimeters. The area of the sector, so the area of that sector is 23.58 square centimeters. Find the central angle theta and the radius. Now, what's tricky about this, of course, is we have two unknowns. We don't know either the angle or the radius. So if I try to go ahead and plug in some values here into an equation, right off the bat, say we start off with the sector equation, theta r squared over 2. We get this equation, but then we have two unknowns. We can kind of isolate the two variables. Theta r squared is equal to 47.16, but we still have two unknowns. So we can't solve that. There's an infinite number of solutions right there, right? So it feels kind of stuck. But we also have the arc length formula. The arc length is r times theta is equal to 7.86. So that's from the arc length formula. So what we can do is just think about this like a system. I have this system of two equations here. Theta r squared equals that. And theta times r is equal to 7.86. I can just take 7.86, isolate it for theta, and substitute it into my equation over here for r. So if I do that, if I go ahead and just make that substitution, it's going to look like this. 47.16 is equal to theta r squared. Theta is worked out from the other equation, 7.86 over r. So we just plug that in for the theta right here. Just going to plug that in. The r's are going to cancel out. So an r squared and an r reduces to just r. So we wind up with this equation, 47.16 is equal to 7.86 r. We can divide by the 7.86 and get our value for the radius. That's going to be 6 centimeters. So then now that we have one of those values, we can take that for r and we can go back to either one of those other equations and figure out the missing angle. So just take the equation that we had for theta that we had isolated from before. Theta is 7.86 over r. Just plug in the 6 for the r and we get theta is equal to approximately 1.31 radians. All right. So that is that.